Hi guys, we're just going to start in a minute or so. I just wanted to call out, you don't have to take screen, obviously the slides for all the sessions at Ignite you can download, but also all of the code that you see today you can actually get from Duncan's GitHub repo.
So both of us will tweet out a link on Twitter, so if you want access to anything, you'll get it. Cool.
So we're waiting for a thumbs up and then we'll kick off.
Wayne's given us a thumbs up.
Are we in the thumbs up?
Yep.
Awesome. Well, hi everyone and welcome to Test Techniques and Practices for Testing Angular 2. I'm Adam Stevenson, I'm a solution architect at SSW, and I'm really happy. I've been spending the last 18 months writing Angular 2 and .NET Core since they were both in early beta, and I also run Fire Bootcamp.
Hi everyone, my name's Duncan. I work with Adam up here in Brisbane. I'm a software architect and I'm also one of the mentors at Fire Bootcamp Online where we teach people Angular. I've been really lucky over the last few years to write pretty much only Angular 1 and 2, all in TypeScript. I've been involved in about a dozen projects in production, and I spend the other half of my time actually teaching people. So we've been really lucky to travel around Australia a lot and around the world teaching people Angular, and we get to do a bunch of code reviews and look into other people's code bases. So hopefully we can share some of that knowledge today, in particular around testing.
So before we get right into the nuts and bolts of it, let's just go through a bit of a history. Who has tested Angular 1 already? Who's written Angular 1 tests? Oh, a few. That's great. Who's written Angular 2 unit tests? Great. Okay, well, you guys are in the right room. So we're going to get you into and show you how you're going to go about writing Angular 2 unit tests today. So a bit of a history. So 1979 was the first time that testing was actually recognised as a separate practice from debugging. So I'm actually older than the practice of testing. So in 1996, Kent Beck described extreme programming that had a real focus on unit testing. And in 1998, he released SUnit, and that was the first unit testing framework which was released for Smalltalk. In 2001, Pivotal Labs released JSUnit, and that was the first JavaScript unit testing framework. In 2003, we got test-driven development, so Kent Beck, so we started getting better processes around our unit testing. Dan North described behaviour-driven development in 2006, so we got more readable tests. And in 2006, we also got Selenium and the ability to run end-to-end tests in the browser. We got Jasmine in 2010, so that was also from Pivotal Labs. So that was the newer, better version of JSUnit for running our tests. And in 2010, we got Angular 1. And Angular 1, I was really stoked with because it was the first time I saw a framework that the hello world was actually included testing. So Angular from the very beginning, since its inception, has had a real focus on being testable. In 2011, we got the Karma Test Runner from Google. Its original name was Testacular, which I think is actually much cooler. I wish they'd have kept it. And in 2013, we got Protractor. And Protractor uses Selenium under the covers and makes it easier to run our end-to-end tests. And in 2016, we got Angular 2. Now, Angular 2 for testing, we write our tests using BDD. It uses Jasmine, it uses Karma, it uses Protractor. So the tools that it's using aren't new, and the practices that it's using aren't new. So they're very well established, but why aren't a lot of people writing tests, especially for their front end? Well, it's still been hard. But the great thing is that Angular 2 gives you a bunch of new tools and helpers that actually make it much easier, and that's what we're going to hit today.
But we've been saying Angular 2 a whole bunch already this morning, so we have to apologize for that. So Angular has announced that they're going to take on semantic versioning, and they're no longer going to have a version number in their name. So it's not going to be Angular 2, 3, or 4. It's going to be more evergreen, so there'll be less kind of big monolithic breaking changes like we've seen. And it's just going to be Angular. And the original version will be called AngularJS. So if you hear us say Angular 2, really we just mean to say Angular. We're all transitioning, everybody in the community, but it's now just called Angular without the 2.
So just like we don't say the version number every time we talk about Chrome.
Yeah, you never say Chrome 44 or...
Yeah. I don't even know what it's up to now.
Neither do I.
Awesome. So what are we going to cover today? We're going to talk about the tools that we're going to use to test our Angular applications. We're going to talk about Jasmine and have a look at, Jasmine's one of the most essential parts. We're going to have a look at that. The hardest part of testing is often managing dependencies, and we're going to have a look at how we can do that in unit testing our Angular apps. We're going to talk about the testbed API, which is an API that we get with Angular that makes it much easier to test our applications. And we're going to look at async and fake async, which are new helper methods that make it much easier to test asynchronous code. Then we're going to look at how to run end-to-end tests with Angular 2.
So let's jump into talking about tools, because it's one of the benefits of using Angular and following kind of the way the community does it. There's a set of tools that's very generic across testing Angular. So as Adam said, Angular was designed to be tested from the ground up. It's not an afterthought, and it was very much the case with Angular 1. It's what it was kind of originally popular for, was that it was the first framework that you could test easily against. But in Angular 2, it's even more so. And if you go look at the docs and you try and print them out, not that anyone prints docs anymore, but if you did, it would be 99 pages long. So just the basics of testing in Angular is a big part of it. So there's a lot to it, and we're going to cover a lot today. So let's talk about the tools, but we're actually going to do a bunch of live code today, and we're going to write a bunch of unit tests. So unit tests look at a very specific part of your application. They're kind of looking at a method or a section of code. And then we're going to write some E-to-E tests or end-to-end tests, which are very different. They exercise your entire application. They actually run the entire thing in the browser and then play with it like a user would and then run tests against that. So we're going to write both of these today. And the set of tools that you use for unit tests, you're going to use Karma as your test runner and Jasmine as your testing framework, which gives you this BDD-style syntax. And we're going to use a bunch of new Angular testing utilities. Now, when you're writing your end-to-end tests, we'll be using Protractor, which sits on top of Selenium WebDriver, and we'll also be using Jasmine. So you get this nice crossover, writing very similar syntax between the two tests. So let's have a look at what Jasmine looks like. So Jasmine very much looks like this. This is a single test in Jasmine. It's got this BDD style of writing where you've got this human language. And this is an it test or a spec. So you'll frequently see your files will have a prefix of .spec.ts. They're TypeScript files in Angular, and that's an individual test or a spec file. So here we've got this test. It takes a string which describes the test. So here it should add 1 + 1, and then it takes an anonymous function that basically has the block of code and your assertions. And here we can see this .toEqual, which there's a whole bunch of these different matches that Jasmine provide. So we normally wrap these in a describe block, which describes a suite of tests. So in here we could have multiple tests, but we could also have multiple describe blocks inside of this describe block. So you can nest everything however you want to nest it as well. So Karma is a test runner that runs your tests. It runs in multiple browsers. It's by far and away the most popular one. And in the terminal, when you run it, this is kind of the output you get. You get this kind of executed 6 of 6 tests successfully, or you'll see some errors. So this is a very popular one. We're using it today. Protractor is very different. Like I said, you don't actually run unit tests, you run your end-to-end tests. So it looks similar in the terminal. You get this output here, and it shows the tests that ran, and it shows you that 2 of 2 tests pass. But it's very different because it runs in the browser and runs the whole app. Now, Wallaby is one of my favorite things, and it's a...
Here we go. It really is one of his favorite things. I hear about it all the time.
So I really like Wallaby. Who's heard of Wallaby JS here? A handful of people, yeah. It's a Brisbane guy. He's on the Gold Coast who makes it. So it gives you live feedback while you write your tests in your IDE. And I have a bunch of stickers to actually give away as well at the end.
Duncan actually had the first Wallaby sticker in the world on his laptop.
I am a bit of a fanboy. So this is what it looks like. You basically have a test, and in your IDE you'll have on the side here a Christmas tree like this that will show you the first test is passing and the second test is failing. And you get this output superimposed over your code that shows you the result of your test. So rather than going into the terminal to get that, you get it here. And on top of that, it only reruns the tests that have changed and runs them in a separate thread, so it's much faster than running the other way. So it's a great tool. You'll see us use it today. I have to say that you do have to pay for it, which is one of the downsides, but if you're writing tests all day, it's well worth it. Now, Angular CLI is a tool that the Angular team are managing that allows you to build a new Angular application from scratch. Just run in the command line ng new and give your project a name, and it will make you a new project. But when it does that, it actually gives you all of your testing harness set up. So everything you see us do today is using the Angular CLI. So if you want to learn to do testing, this is the best way to go, because within a few minutes, you've got your whole testing harness set up, and you can do pretty much what we've done today straight away. And it's a great way to start your real applications as well, because one of the big parts is it actually bundles your application for production in a one line as well, which saves you writing your own build process, which is great. So in summary regarding tools, we reckon you should use the Angular CLI because it sets all your testing up. And we think you should use Karma, Protractor, and Jasmine, even though there's options to use things like Mocha and Sign-On as testing framework. The Angular communities, pretty much everybody's using these tools, so it's very popular and it's going to be much easier to find documentation around it. And we think you should check out Wallaby.js for getting live feedback for your tests. So we've been talking about tools, and we're going to jump in and talk about one of the tools in particular and do a bit of a code demo, and that's Jasmine. So it's a testing framework. It gives you much more than just the syntax. But what are we going to test today? So we've got Chuck Norris jokes application we've made here, and it's just a single page. We've pre-written it. It has no routing. All it has is a H1 element at the top, which has this Chuck Norris jokes, and then it has a bootstrap well with a paragraph element in it that actually has the joke there, and then this big green button that we can hit, and it will show us the next joke, and we can hit again, it will show us the next joke. So this is a really simple application, but it's a great way to talk about testing because it shows you the kind of common workflow that you'll run into as soon as you start testing Angular. You have a component, there's button clicks that talk to a component, and the component talks to an Angular service, and that means you've got a dependency on that service in the component, and you have to mock it, and then your service calls a backend, so you've got to make HTTP requests, and then you've got to receive the response and then put it back into the DOM, or the document object model, or another way of saying HTML template. So we've got to do all these steps, and we'll see it working through these steps today, which is a great way of talking about it. So let's jump into a code demo and actually write a bit of Jasmine here. So I've got Visual Studio Code set up, and we have a default application running. And it's just logged me out. So I have Visual Studio Code here running, and on the side here you can see that we have a default CLI application. And the important thing to see here is we have this app folder, and in here we have all of our logic for this app, and we have a joke folder. And in our joke folder we have a single joke component. So in our joke component, there's three things I want to point out here. We're not going to troll through it, it's pretty simple. Is we have a joke property, which we're going to initialize from a value we get from our database. And we have a title property, which we've just got a hard-coded string, and we're going to test both of these things throughout the session today. And then we have a getJoke method, and this getJoke method calls our joke service, our Angular service, which now means this component has a dependency on this joke service, and we have to learn to deal with faking this in our tests. So if I pop over to this joke.component.spec.ts file, you can see that we have an empty test here. So we're going to write some tests in here. I'm just going to give us a bit more room. And I'm going to do a Jasmine describe block here. I'm going to say we're going to describe a component. And this component is going to be the joke component. And in this joke component, we're going to have a it block, as you saw before. So I'm going to say it should add 1 + 1. I like to do this sort of test at the beginning of each of my testing files because because usually you've got a bunch of setup to do, and you want to see that it's actually working. This is a simple way to get a bit of sanity. So in here I can come in and say that I expect 1 + 1 to equal 3. And we all know that's not true. We all know that 1 + 1 = 2. And I'm going to open up the terminal at the bottom, and I'm going to run ng test. So ng gives us a handle on the Angular CLI and all the things that it can do for us, and it can run our tests. So I'm going to run ng test, and what it's going to do is it's going to kick off Karma. Karma will build our application and watch for any file changes and rerun tests as we go. And you can see at the bottom here it's saying that we expected 2 to equal 3, and we have 1 failing test here at the bottom. So we can come back up to the top, and we can change this, and we can say that 1 + 1 = 2. And then we'll rerun the tests, and it's going to pass, and we can see at the bottom it was very quick, executed 1 of 1 successfully. So this is like the very basics. We're going to build up from here and we're going to do a fair bit more today. So I'm just going to kill this server down here, the Karma server, and clear out the terminal and move it aside. And I'm actually going to start Wallaby. So Wallaby start like so. And you can see it kicking away in the bottom right-hand corner. We've got this little bar that's kind of loading here. And then we're going to see on the left, we're going to see these green dots pop up. So I can come in again and change this to make it fail and say 1 + 1 = 3. And then we see the outcome of the fail, why it's failing on the side here. So we're going to use Wallaby for the rest of today. I'm going to change this back to 2 and make it pass. So that's the very basics of a Jasmine test. But I'm going to write one more test here. I'm going to come in and I'm going to say that it should have a title of Chuck Norris jokes, like so. And just going to copy this so we can write a test against it. And in here, we can come in and we can say, I want to have a component. So I'm going to make a constant for component. And I'm going to set it equal to a new joke component. But we have a problem here with this joke component, and that is that it expects to get a joke service. So if we look in here, it's expecting a joke service. And we're going to come back and talk about faking dependencies in a second. But for now, I'm just going to pass in null to get this to pass. And I'm just going to test the title property on our components model. So to do that, I can do a Jasmine expectation, and I can come in and I expect my component.title. And you can see one of the benefits straight away here of TypeScript. So all your tests are in the same way that you write your actual Angular code now. So it's really handy to have all of the IntelliSense straight here. So I can say I want to test this component.title. It's already saying that it's failing and showing why, and I expect it to equal Chuck Norris jokes, and now it's passing. So hopefully you can see some of the basics here of how you would use Jasmine. So we just had a quick look at some tests with Jasmine. We saw we have describe blocks, and we can have these nested it blocks. And it's the default for the Angular community Jasmine. So that's the big thing to take away. It's probably the testing framework you're going to want to use. And it's much more than just syntax that you've seen here in matches. There's a whole bunch of things you can do for faking dependencies, which Adam's going to talk about now.
Excellent. So faking dependencies. Faking and the setup of dependencies is still one of the hardest parts of testing. If you've written unit tests in C#, you know that it's one of the biggest challenges in C# as well. So we're going to talk about how we can make it easier in Angular. So the scenario is that we have a joke component, and you saw that the joke component has a dependency on this joke service. Now, Duncan, to get his test passing, just passed in null. But when we're actually testing code that actually uses that service, we need to pass something in that can actually be used. So one method of doing this is to pass in a fake. So I can actually just create a fake object and put the method that my test requires onto that, and then give it a return value that I know about, and then I can test against. So that's one method of actually managing our dependencies. But Jasmine helps us out. Jasmine has a test double called spies. And what I can do with Jasmine is I can create a spy object, and I can say, go and create me a joke service and put a get joke spy on that service. And then I can say, when the get joke method is called, actually go and return me this value. So they're the two different methods. We can either use a fake object or we can use Jasmine spies. Now, there's a benefit to using spies. So spies let you intercept any function call, and they let you override the behavior of the function. But on top of that, what they also let you do is they let you check to see whether that method was actually called. They let you check how many times a method has been called, and they also let you check what parameters were passed to that method. Let's go and have a look at what that looks like. So before I go and have a look, let's just go and have another look and familiarise ourselves with the joke component. So we can see in the component, when it's instantiated, it's got the constructor, and the constructor accepts the joke service. Now, but when the component's initialised, we call the getJoke method. The getJoke method goes to our joke service, and it gets the jokes, gets a joke, and when it returns it, it assigns the joke to the joke property. So now I'm going to write a test that makes sure that when we call ng on init, the joke property is set. So I'm going to come in here and I'm going to make a new test. And I'm going to say it should set the joke property when initialized. Okay, now I'm going to come in here and I could come in and make a new instance of the component. But you can imagine if we had 20 tests in our describe block, I'd be typing this 20 times. So I'm going to try and keep my code dry, and instead I'm going to come up and in my describe block, I'm going to say let component, and I'm going to make it a joke component. And then what I'm going to do is I'm going to use a before each. Now the nice thing about a before each is it'll execute before every test. Okay, so I can come in here and I can say that what's going to happen before every test is I'm going to go and I'm going to move my instantiation of my joke component up into my before each. And do a little bit of tidying. And you can see that my test's passing again. So a little bit of refactoring and my code is more dry. So I'm following do not repeat yourself. So now I can come in here and I can call component.ng on init. Oops. And now I can do my expectation. Java expect, and I'm going to check that the component's joke property is equal to some string that I know about. Okay, but remember, ng on init is calling that service to go and get a joke, and then we're testing that string. So I need to pass in a fake into my joke component so that it knows when it calls that get joke method what's going to be returned. So I can come in here and actually create the dependency. So I'm going to create a fake joke service of type any. TypeScript is wonderful. And now what I'm going to do is in here, I'm going to create an actual fake. So I'm going to say that my fake joke service is an object. And on that object, I'm going to have a getJoke property, which is a method. And what I'm going to do is I'm going to get that method to return an observable of fake joke. Now, I'm going to have to go and grab of from RxJS. So I'm just going to import, they call it the RxJS kitchen sink. And this is basically go and grab the whole library. So I'm going to go and grab Rx, so that will give me everything. And I don't need that semicolon there. So now I've gone and I've created a fake object called fake joke service. I've put a method on it, so when I call getJoke, I know what's going to be returned, and I can now pass that into the constructor of my joke component. So now you can see Wallaby's telling me that it's already getting back fake joke. So I come in here and I'm expecting it to be fake joke, and you can see my test is now passing. Pretty cool? Now, instead of actually using a fake up here, what I can do is I can actually use Jasmine. I can use a Jasmine spy instead. So what I can say is I can say fake joke service is jasmine.create spy object. And the create spy object function takes two parameters. I'm going to pass in my fake joke service. And the second parameter is an array of properties. So I'm going to pass in, so I'm going to say I want a property on that fake joke service called getJoke. Okay, now that doesn't add any behavior to it though. So what I want to do is I want to say fake joke service dot getJoke and return value, and now I can specify what value I'm going to return. Observable of fake joke. Now, if I've done this correct, you can see my test is passing again. So they're the two different ways I can do this. I can either create a fake object or I can create a Jasmine spy. So what we've just seen is I went and I refactored to use a before each. I created a fake object and assigned the behavior in the fake object, and then I went and used Jasmine to perform the same thing but using a Jasmine spy. Now, the nice thing about spying is that it lets us override functionality, and it lets us do assertions as well, and we end up with much cleaner code. Now, a lot of people like faking because it gives you a better feeling of isolation. The downside is that you can end up with more duplicated code, and you can sometimes end up in the situation where when the service is updated, you forget to update the tests. So that's also a downside.
And I think this is also a spot where you'll find as a team you're going to need to make a decision. So you'll have to decide, are you going to go down the road where you make fake objects? And we see this very much out in the community. People go one of the two ways. Or are you going to spy on objects? And there's a bit of a trend more towards spying because of that reason that Adam said, is that you don't have this duplicated code because people are finding that they make another object in their test, and then someone updates the real implementation but forgets to update the test, and then it goes through to production and they didn't catch an error. So you've got to, but neither one is right or wrong, but it's something your team will have to decide on, and it's probably worth playing with both before you make up your mind.
Definitely. So you need to get your head around both fakes and spies. You need to have both of them on your tool belt. And faking and the setting up of dependencies is really still the hardest part of testing. Now, the great thing is that with Angular 2, we get the test bed, and the test bed is really going to help you out, and Duncan's going to talk about that next.
Cool. So let's talk about this testbed API. It's the big new thing that comes with Angular for testing, and it's a big API. And there's a fair bit to learn about it, but it's one of the big benefits. But before we jump into that, there's 3 types of tests you'll hear the Angular community talk about. And the first one is isolated tests. So this isolated unit tests are the ones that we've been writing so far. We haven't actually done anything with our HTML templates. We've just been interacting with the methods and the properties on our component class. So these are isolated tests. We just said new joke component, newed it up. But the other type is a shallow test. And a shallow test does interact with the HTML template. You actually query the template, detect changes, and make sure that the things that you're doing in your test have actually changed the HTML. So you normally do this with just a single component. You don't look at the nested components. But this is a shallow test. The other type of test you'll hear people talk about are integrated tests, where you actually run the entire application in your unit test. We won't talk so much about these today, but we'll be running some shallow tests now, and this is what the test bed will help us do, be able to actually test the HTML templates. So this is what a test bed looks like. If you've done any Angular before, or the new Angular, this looks very much like an Angular module, and an Angular module or an NG module basically allows you to say, for this section of code, this feature or section of code, these are the dependencies. So the same thing in a test module, when we say testbed.configure testing module, we're saying for these tests in this test suite to run, these are the dependencies we have, so we can isolate, and it makes it much easier to set up our test suite. So here you can see that I'm importing the HTTP module because I have a dependency on that to be able to call my backend. And then we have declarations, which are your components. We only have a single component here, the joke component. And we have our providers, which is where we register our Angular services. So here we've just got this single joke service. But now we're actually passing in the real joke service, not the fake one. So once we do this, the whole reason we do this testbed stuff, well, there's actually a lot of benefits, but the big benefit is we get a hold of this fixture. And we can say testbed.create me this joke component. And with this fixture, we can get a bunch of stuff. We can actually get a component instance, which is like newing up the component. We get its class, properties, and methods. But then we get this debug element, and it's the debug element that allows us to then go debug element query and query the HTML template. But we can also say, fixture, can you detect changes because I've changed the HTML template? So this debug element looks like this. We go debug element.query, and we can query by CSS, and we can get, in this case, the first paragraph element. But we also have this .native element, which we can put on the end, which means that we're going to actually have access to using the DOM API from the browser and all the things that we would expect if we were in a browser environment. So the testbed API helps you do a bunch of stuff. It helps you create a testing module and makes it much easier to set up your dependencies. And it allows you to query HTML templates. We're going to do a code demo of that now, and allows you to detect changes and a bunch more things, which you'll see a few of them. So let's jump into a code demo, and we're going to have a look at setting up a test bed. And I actually get the benefit, one of my favorite things of today is coming in and removing Adam's code.
You like doing that at work too?
I love it. Okay, so I'm going to come in, I'm going to remove his code here, and this is what it would look like when you're probably setting up this test here, is you would have an empty before each, and you'd come in and you'd put your test bed here. So you can say test bed, and you can say dot create, is it create? Configure. So we've got a testbed got configure testing module here, and this takes an object, and we can pass in our imports here, and our imports are going to be an array, and we only have a single one here, which is the HTTP module. And we're going to need to import the HTTP module. And then we have our declarations, which are our components, and we're just going to have the joke component. And then after that, we have our providers, and we only have the joke service here. So with this set up, we can go and make a few properties which we're going to initialize in a second. And the first one is going to be this fixture, this all-important fixture that we want to deal with. So it's going to be of type component fixture, and that will be of type joke component. And then we can go, we also want to have the component we were dealing with before, so that will be of type joke component. And then we want to get this debug element. Now I'm going to set it to DE. You see this quite commonly, people just putting in the initials so that it's easier to type. So DB is going to be of type debug element, and that's what's going to allow us to do the queries. And we also have this joke service. And I'm going to do it with a lowercase j here, but we're actually going to use the real joke service and spy on it. So I'm going to call, this will be of type joke service. So with all of these set here, what we can do is we can come down and initialize them. And first of all, we're going to get this fixture. So I'm going to say fixture equals testbed dot create me a component and pass in the joke component here. Now I've got this joke component, I can get the actual component, initialize it. So I'm going to say component equals fixture dot component instance. So you can see this all-important fixture here, and then I'm going to get the debug element, and that's going to be de equals the fixture dot debug element. And then the last thing we're going to do is kind of, you've got lots of choices here on how you inject your dependencies. So we want to set this joke service property that we have to be a joke service. So I'm going to use the testbed again for that. So I can say testbed.get, and it's a very simple way of doing it, which works well when you don't have many things to inject, and say, I want you to get me a joke service here. So with all of these things set up, we actually have a problem here, and everything's failing, and we can actually see that even my 1+1 is failing, and I just happen to know that with my test runner you need to restart it. So I'm actually just going to use the keyboard shortcut and stop. Well, actually, I'll just do it up here so you can see it. So we'll go Wallaby, start, and I'm just going to restart Wallaby so that it picks up this new configuration in the testbed here. So when that restarts, we'll see the green dots come back, and we can come down and we can see now that we're no longer actually configuring the spy that Adam had before, so we're going to have to change his code again. So I'm not going to use this ng on init here, and I'm going to pass in a spy on. So we're going to spy on this joke service, the real joke service, and we're going to be spying on the get joke method, and we're going to do the similar thing where we say and return values will be, or the return value is going to be an observable of a fake joke. So we can just say fake joke here, and this is actually going to be a string. So with that set up, we now can come in and say, fixture, can you detect changes, so that you can actually detect that when the component initialized, can you actually detect the changes that it made, which was to actually set that joke property. So we can say here, fixture.detect changes, and then after fixture.detect changes, we can actually go get a hold of this joke property. So I'm going to say const of element, and this is going to equal debug element.query. And this is why we go to such extent here, so we can actually query our HTML templates. So here I can say by.css, which is the way we'll query, and I want to query the first paragraph element here. We're going to need to import the by property. So by.css there, and I want to deal with it with the native element, like I've got the DOM API available, so native element here. So with that done, we can see that everything's actually almost still passing here by pretend, so I need to change the expectation. And what I want to do here is I want to say that the element.text content is going to equal our fake joke that we're passing in from above. So we can see now that we've reached into the HTML and we've actually accessed and we're checking that the actual DOM was updated with the joke, and we've intercepted and passed in fake joke for the joke.
Cool.
So we've run a couple of demos here, and we've gone and we set up this test bed, which makes it much easier to set up your dependencies, and all importantly, we've been able to do this querying of the DOM. So the testbed API is great. It takes a bit of time to learn. It's definitely a big API. There's a lot more to it than you've even seen here, and lots of options. Like I said, the docs are 99 pages long. And it makes running an ng module, or kind of it sets up an ng module for you for all your dependencies, and it runs all of those in a zone. And if you're anything like me, the first time you heard this, you're like, what is a zone? And that's what we're going to talk about next.
So async and fake async. So async adds complexity to writing JavaScript unit tests. There is as web developers, there is asynchrony everywhere. You click a button on your HTML, that goes and calls a service, and that takes time to return. Even when you've got a bunch of data and you're binding it to the page, that doesn't happen instantaneously. There's asynchronous operations that are going on all throughout our applications, and that can make writing tests really complex. So we've been able to do this before using Jasmine done callbacks. So we've been able to go through and put our tests together, but we need to use the done callback to actually say explicitly, here is where we're done now and you can execute. So the downside of done callbacks is that they require chaining promises. You need to handle errors and you need to manually call done. So while you still need to be able to do this on edge cases very occasionally, but it's not really recommended, there's much better ways of doing it now. But how they've facilitated these new improvements, which is with the async and fake async keywords, is using zones. So what zones do is they define an execution context for asynchronous operations. So what that really means is that when you're writing your components, when you do any async operation, if you go and you call a service and that service has to go and do a request, or when the data is binding, there's actually a thing called a microtask queue. So you've got an execution context and you've got little queues, and every time an async operation occurs, that async operation is put on a queue. So what we're able to do is we're able to know when the queue gets down to 0, all the async operations have completed. And that's really all a zone is. So what's cool is that when we start writing our unit tests, we actually have a special test zone. So now any async operations inside our unit tests are happening inside this test zone. And we don't need to specifically go and say, hey, everything's done now, because our test can know when all the async operations have completed because the queue goes down to 0. Pretty cool? Let's have a look at what it looks like in code. So we can use the async function. And when we've got the async function, we can go and do something that calls an asynchronous operation like a button click. And then we can use fixture.whenStable. And fixture.whenStable resolves when all the pending asynchronous activities within that test complete. So we can wait, we can say, go and do the button click. That button click's going to go do some asynchronous stuff. And when the queue of microtasks gets back down to 0, we know that everything that's happened that needs to happen, and then we can go and do a round of change detection by calling fixture.detectChanges, and then we can do our assertion and know that everything's where it should be. So that makes testing our async code much easier. We've also got fake async, and I really like fake async because it's a very linear progression through your test. So we call button click, and then we use tick. And what tick does is it simulates the passage of time until all of those asynchronous operations have completed. There's also an option where you can pass in a parameter and it's saying wait or simulate waiting that number of milliseconds. So then I can call tick, pass in a value, then I can do my detect changes and then do my assertion. Let's have a look at what that looks like in code. You went and deleted my code before, didn't you?
Yep.
Okay, I'm going to one-up you. So I'm going to take, Duncan's test is okay. But so what he's doing is he's going and he's checking that when the test runs, that the joke is returned and is being displayed on the page. I'm going to take his and make it better, because that's what I do. And I'm going to test that when we actually click the button, that it goes and gets a second joke and binds a second joke onto the page. So I'm going to take his OK test. I'm going to copy it and I'm going to paste it in. And I'm going to make my test that it should show a new joke when button clicked. Cool? So at the moment, in Duncan's spy, he's returning a single value. So I'm going to need two values, because I'm going to get one when the component loads, and then I'm going to get another one when the button's clicked. So I'm going to change this from return value to return values. And for my second one, I don't think I want to do dictation. What I'm going to do is I'm going to copy that, and I'm going to make my second one fake joke 2, and to have a little bit more fun, I'm going to put a timeout of 2 seconds in. So what's going to happen is the first joke is going to be returned from the spy instantaneously. The second one is going to simulate a long request out to a web server and is going to take 2 seconds to return. Because I'm having some fun with time, I'm actually going to wrap this in the fake async method. So I'm wrapping my test in fake async. So that means the test is going to execute within that test zone and lets me have more control over my asynchrony. And I've probably got to import fake async. I'm actually going to come up to the top, and in testing, I'm going to import a few keywords. I'm going to import fake async, I'm going to import async, and I'm going to import tick, because they're the couple of things I'm going to use. Okay, so now I've got a fake async test. I've updated so I can return 2 values. I'm doing detect changes. I'm doing an assertion to test the initial value. But now I'm going to go and I'm going to get a handle on the button. So I'm going to come in here and I'm going to create a variable for the button, and I'm going to get it from the template by doing CSS by button. Now I can just go and call button.click. Yeah? And then once I do button.click, I can do a fixture.detect changes to do a cycle of change detection to let the page update. And now I can do another assertion. And I'm going to assert that the text content is now equal to fake joke 2. But what I need to do to get this to work is I need to come in and do what do I need to do with a fake async? A tick. Because I'm saying wait 2 seconds, so I need to come in here and I need to say go and do a tick for 3 seconds, or I could do 2 seconds, and once I do that, then I can go and make sure that my expectation is equal to fake joke 2. So that's how I can use an async test zone to actually make testing my asynchronous code easier. Now, if I didn't want to use fake async, if I just wanted to do it using async, I can't do a timeout. I'm not going to do the timeout. So I'm going to come down here. Now, it's telling me that it's failing because of the tick. So I can't use tick. What do I use in an async test? When stable. So instead, I'm going to go in here and go fixture.when stable, then, and when I do when stable, so I'm going to use when stable instead of doing the tick, and I'm going to move my detect changes and my assertion inside of when stable. And so you can see here when I remove the tick, it'll go back to parsing because now I'm using the alternate method. So I use tick with fake async, and I use when stable when I'm using the async callback. So what we just saw was we saw writing async tests and how it makes it easier to manage our asynchrony. So I can then use click and use the when stable to resolve that and do my assertions, or I can do a fake async test and use the tick keyword, use the tick method. So the nice thing about the async function is it simplifies the coding of our asynchronous tests. I prefer fake async because you get a nice linear flow through your test and it appears to be more synchronous. The downside is you can't use it everywhere. So for example, you can't make XHR requests inside a fake async test. So in summary, async code has always been edgy to get right. But we've got these great new helper functions that really help us out.
So let's switch gears for a second here. We've been talking about unit tests, and let's have a look at running some end-to-end tests, because that's a big part of the story for running Angular. And it's actually a trend that we're seeing a lot more, that people are liking to run end-to-end tests and moving towards doing more end-to-end tests, whereas traditionally people on the front end have done lots of unit tests and a little bit of end-to-end tests. So end-to-end tests are very different, like I've mentioned before, than unit tests. Their goal is different. A unit test is very pinpoint radar. It's kind of telling you this method has a problem in the way that it's working, whereas your end-to-end test is more, your purchase button's not working in IE and your butt's on the line at work. So very different type of test. So we're going to jump in and write a couple of end-to-end tests that finish up here so you can see Protractor working and some of the TypeScript features. So I'm going to close this page down here and just go open up the Explorer here on the left. And you can see we've got this E to E folder here. So this comes pre-set up from the Angular CLI. And we're not going to use page objects methods today, which is a style of setting up your tests. We're just going to write a straight test here in this app.e2e-spec.ts file. So everything's set up and ready to go, but we have no tests. So first of all, I need to import a couple of helpers here. So I'm going to import from Protractor a couple of things. So first of all, I want to get browser, and browser is going to allow me to navigate between pages, and then I want to get element and by, which are just two helpers that are going to allow us to be able to select the DOM. So then I'm going to do another Jasmine describe, and like I said, you'll find it's a very familiar syntax to your unit tests. So in this describe block, I'm describing a page, which is hopefully helping people kind of do the context shift here from unit tests. We're not looking at a single component, we're looking at a page that might be full of components. So here we're looking at the joke page. Now, inside of here, we're going to put in a it test. So I'm going to say should have a title of, and it looks very similar to our unit test, Chuck Norris jokes. But the difference is here is I'm actually going to run this in the browser and then check against this. So let's just copy this. And first thing I need to do is navigate to the right part of the page. So in this case, I'm going to use the browser helper here. So I'm going to say browser.get, and I want you to get me the path of just slash. So we're just going to the root of our application. And then once I'm here, I want to have a constant set up for this title. So this title is going to be element, and it looks very similar to before by CSS, and this CSS is going to be the H1 element. So our title of our page, this Chuck Norris jokes, is in a H1 element. And then I'm going to say, can you get me the text for it? And once we have this, we can do an expectation, and we can say that I expect that my title property is going to equal, Chuck Norris jokes. Now, this is very different than running we don't get some nice tool like Wallaby here, because these tests run in the browser, they take a lot longer. So I'm just going to give us a bit more room here and open up the terminal. And before we ran ng test to execute our unit tests, so we're going to do something similar here, and we're going to run ng e to e to run our end-to-end tests. And I'm actually going to pop this over to the side here, and you're going to see a flash of a browser. So when this runs, it's going to build our application, serve it up, Protractor is going to run it in Chrome, and it's going to actually test the title and then shut down. So you have to be fast to see it here on the left. So it's building, and then it will flash up on the left of the screen here. runs the application, checks the title, and then the test is passing. So we can come in and run another test here. I'm just going to go back to doing full screen, give ourselves a bit more room. And we're going to do one last test here, and we're going to look at some of the new TypeScript syntax. So we're going to say we should have a different second joke here. And it's going to look like we have above. We're going to always, because every test is going to be different, we're going to browser.get, and we're going to go to the root again of the URL. And once we've done this, we're going to set up another constant here, and we're going to set one up for each joke. So we're going to have joke 1, and this is going to be equal to element by.css. And this time we want to get the paragraph element, and we want to call getText again to get its text. So we call getText, and we're going to want 2 of these, one for the first joke and one for the second joke. But before we get to get the second joke, we actually want to click that big green button. So I'm going to do element, again, by.css, and we're going to grab the button, and we're going to call .click on it. So, like so. But I'm a little bit concerned. In this case, it will probably just work for us here. We can probably just do a Jasmine expectation and say that we expect that joke 1 is not, we can use the not matcher, not equal to joke 2, like so. But I'm a little nervous here that maybe by the time we try and set this second joke on the button, that it takes too long to get back the value, and actual joke 2 is not set. Maybe we have some async issues here. So we can use, because this runs in Node, we can use ES6 version of JavaScript versus ES5, and we can use some of the new language features like async await, which is very different than Adam's async await that you saw in the unit test. This is TypeScript's async await for dealing with promises. So I'm going to use a async keyword here in front of this function, and I can then come down here, and this getText returns a promise when it resolves. So in front of here, I can say I want to await this element. So it's going to block on this line, and it's a really nice use of these new language features for dealing with promises and async await in TypeScript, because I don't have to deal with catching any errors or anything. It'll just time out. All I want to do is just block until it resolves. So I really like this. It's fun using some of the new language features. Okay, so with this working, we can come back and open up the terminal again, clear it out, and we can run ng e to e again. And this time it's going to run the first test, then the second test, and the second test will click the button and try and check the second joke. So we'll run these again. And it's going to pop open again to the left. Check the title, close down, start it again, check both jokes and close, and then you see it's checking that the second joke was set. So we just had a look at 2 simple end-to-end tests, and we looked at how we can do a browser.get, and then we looked at some of the new language features with the async keyword. So in summary, for end-to-end tests, they're very different. They're not a unit test, they're a lot slower. And they test user stories versus functions and methods and so forth. And I really love them because they help save manual testers, and people don't have to spend their life doing manual testing.
Cool. So something that we really need, one of the messages that we really want to get out is that, it's great that you guys are here and you're learning about testing, and you're obviously interested in testing your front-end applications. But what we find is that testing is really something that the whole team needs to practice. So you really need to get buy-in from the whole team. Otherwise, you'll write tests, someone will go and change your code, your test will break. And what do? Do they go and spend a whole lot of time learning testing? No. If they don't know it, they comment it out and think, oh, he won't notice. So we think, it's great that you're here, but you really need to get the whole team on the board. And on board, and that it's something that the whole team needs to practice and practice regularly.
So we have a giveaway today. We run Fire Bootcamp. We do 2-day training courses. We've got one in Brisbane coming up soon. We do 6-week online courses, and we've got a set of documentation we run people through to teach them testing. So you can see it on the screen here. It was a lot of fun to make. We used Angular 2 and some cloud functions and Polymer and a bunch of other goodies. But we've got everything that we've just run through and a lot more in detail here that we're going to give you a coupon that you can access. So these are the docs, and you can run through, as you can see, all the steps and all the code demos that we have. for doing exactly what we've got up on stage. So if you want to get access to this is the URL. We'll keep it open for about a day. So the course is www.courses.firebootcamp.com. And when you try and access any of those lessons, it will ask you for a coupon and you can pass in Ignite-testing. So I'll leave that up for a second if you want, and we'll keep it open for most of the day.
We've only just released it, so we're super keen on feedback too.
Yep. Okay. So in summary,
what have we had a look at? We've had a look at the tools that you can use for Angular 2 unit testing. We explored Jasmine and showed you how to use it and how great it is. We had a look at, what's always been a challenge with unit testing and how to manage your dependencies, how to fake your dependencies. We looked at how Angular is giving us the testbed API, and that is really going to help out with writing our unit tests. And we also looked at the great async and fake async methods, which really simplify testing our async code, and we saw how to run end-to-end tests. Look, we just want to thank you very much for coming along today, and come up afterwards and ask any questions. Thank you very much.
And books.
We've also got some Angular 2 books. We actually wrote a book called The Little Book of Angular. So if you want to come up and grab a book, we've also got books to hand out.
And Wallaby stickers.
And Wallaby stickers. You should seriously check out Wallaby. It will save you a bunch of time.
What do you want us to say? So we also have Angular Superpowers Tour, where we're going to be running a one-day event. So Brisbane, Sydney, Melbourne. There's a flyer here that has the details and also our contact information if you're interested in joining us for the 2-day course in Brisbane coming up.
I might put some on the other end down here as well, just to break up the crowd.
Cool. I'll give these stickers out.
We should put them in 3 different locations to see who wants the stickers and who wants the book.
Sticker.
These are magnets.
Yeah, there's magnets there if you prefer magnets, and there's stickers. There you go. You want to take 2?
Oh, and there's
There you go.
there's the flyers for the Superpowers too.
Yeah, guys, this is a tour that Adam and Duncan are doing in April in Sydney, Melbourne, Brisbane. So it's a whole day of training. So if you guys want to find out more.
No
worries,
worries.
thank you.
If anyone has got any questions too, we've got about 10 minutes if you've got any curiosities or you've been writing tests and you want to give us some, you want to tell us about the things you're really liking or the things that are causing you pain. We're always interested in what other people's stories are.
Which means we probably mute this now.
Yeah. Unless you want to do a quick song.